Hey all, we are going to talk today about domain and range. This is lesson 1.1 from your Algebra 2 curriculum. We are going to talk about end behavior as well. We're going to kind of do an overview here, and then I will have some extra videos to tell you a little bit more about specific topics. Our goals for this lesson are to be able to determine the domain and range of a function, especially when we're looking at the graph. We also want to be able to talk about the end behavior of a function and figure out what that's doing on the graph. And then thirdly, we want to be able to use the correct notation to talk about or describe the graph's behavior. We're going to give examples of how to correctly notate both domain and range as well as end behavior here. First of all, you probably need to know some vocab. So here's some informational words for you. You need to know what an interval is. You need to know that an interval is the part of the graph that doesn't have any breaks. And each break actually signals a new interval. So you can kind of see that first one there. It goes from -1 to 2. That's the interval. There's no breaks in between there. The second one actually has two intervals. So from 4 to 7, or 7 down actually, is an interval, and then from 11 up is an interval. We have two there. You can see that the graph kind of breaks here in the middle. When we talk about intervals, there are two different kinds. You have a finite interval, which has two distinct endpoints. It starts, it stops. You can see that on the graph. And you have an infinite interval, which either goes on forever in one or both directions. You can see this finite interval, it's starting at 0 and ending at 3. This infinite interval is starting at -2 and it's going down forever. So that's kind of the difference between finite and infinite. You also need to know what domain and range are. These are really important. You need to know that the domain is all of the x values and that the range is all the y values for any given function. You need to be able to separate them. So when we're talking about domain, we are talking about the horizontal distinctions of the graph. And when we talk about range, we're talking about what does the graph look like vertically, okay? So horizontal talks about left to right, range talks about up and down, and we do kind of have to separate them. Graphs have both of those together. Specifically, when we're talking about end behavior, we have to know what is happening to the graph as it's leaving to the right at positive infinity, and as it heads off the graph towards the left to negative infinity. We have to talk about what is the graph doing? Is it increasing, decreasing, what's happening? So when we talk about domain and range, we're separating the horizontal part of the graph from the vertical part of the graph. And then the end behavior talks about what are they doing. So let's look at a graph here. You can see we have the graph of a line, just a plain old line. It's got the arrows on the end, which tells you that you're going on forever. Let's start with the domain. How is the graph described width-wise, okay? Kind of you want to ask yourself here, does it have an ending point? The arrows tell us that this graph is going to continue to get wider and wider and wider as it goes out. It's going to continue both to the right and to the left forever. So when we talk about that for domain, we're going to say that the leftmost end point, if you will, and I'm air quoting that, is negative infinity. And the rightmost point is positive infinity. So this graph will continue to go to the left forever and to the right forever. Same with the range, actually. It will continue to go down forever to negative infinity, and it will continue to go up forever to positive infinity. Notice how we kind of separated that. We talked about going to the left and the right, and then we talked about going up and going down. Okay, we're kind of separating the domain and the range. Now the end behavior asks, what is happening to the y or the function as it's going off to the right and the left? So as x approaches positive infinity, so as the graph heads towards the right, what is happening? It is increasing or going up. So we would say as x approaches positive infinity, f of x or y, they are used interchangeably, also approaches positive infinity. It's increasing. Then we look at negative infinity. So what's happening to this function, this line, as it goes off to the left? It's going down. So as x approaches negative infinity to the left, f of x is approaching down or negative infinity. I hope that makes sense to you. Domain is simply what's happening to the graph widthwise, range is what's happening to the graph vertically, and behavior kind of puts it together, what's happening to the graph as it leaves to the right and to the left. Okay, let's look at another one. So here we've got a parabola, which I hope you remember is the graph of a quadratic equation. We're going to talk about the domain and the range first. So domain, what's happening to this graph widthwise? We know that these arrows mean that it's going on forever, right? So as the graph leaves, it's going to continue getting wider and wider and wider and wider forever in both directions. So we would say again that the domain is negative infinity to positive infinity. Domain of many, many, many functions is negative infinity to positive infinity. Very often, I won't say always, but very often, especially when we are talking about a function, your domain is going to be negative infinity, positive. The range, however, is a little different. So the way I kind of like to look at this is there a bottom or a top point or stopping point of this graph? You can see here that this graph bottoms out at -6. It goes no lower than -6. That's the bottom range of this graph. So I'm going to say -6. Now this gets a little different. I'm not going to use a parenthesis. I am going to use a bracket because the graph does exist at the point -6. If you think about it, we use a parenthesis for infinity because the graph doesn't exist at infinity because you can never get to infinity. I know that's a little, some deep reasoning there, but if you think about it, nothing can ever reach infinity because as far as you've gone, there's always a little bit farther, right? So that's why we use the parenthesis to talk about positive and negative infinity because we can never actually reach that point. When we talk about -6, the graph is there. The graph is at -6, it's reached that point, and then it turns and goes back up. So we know that the graph exists there. Now, how far up is this graph going to go? Clearly, the arrows tell us it's going to keep going up and up and up forever to positive infinity. And I'm going to use my parenthesis again because I'm not reaching positive infinity. I hope that makes sense to you. I know that's a little bit of a different. If it helps, remember way back when we talked about less than and less than or equal to? The difference is that the graph does not exist at that point, or it does when it's equal to. Okay, so let's add, the same thing is true of a parenthesis and a bracket. So if you have a less than sign, you have an open point and you have a parenthesis. If you have a less than or equal to, you have a closed point and you have a bracket. Kind of think back to those graphs, whether you would use an open point or a closed point, the same is true of a parenthesis versus a bracket, okay? So if that kind of helps you, include that little chart in your notes. Let's talk about the end behavior of this graph. So what's happening, first of all, as x approaches positive infinity? So as the graph goes to the right, what's happening? It's going up. So I would say as x approaches positive infinity, f of x approaches positive infinity. It's going up. What's happening towards negative infinity? So as the graph goes left or towards negative infinity, it's also going up. So as x approaches negative infinity, f of x, or y, or the graph, or however you want to think of it, is also going up towards positive infinity. So you kind of have a couple different options. Usually the graph is either increasing or decreasing. So as you go to the right, is it going up towards positive infinity? Is it going down towards negative infinity? Same thing to the left. And then you just write your end behavior notation as what f of x is approaching. I hope this works for you. This is kind of an overview of our lesson today. If you are interested in more information about domain and range, or end behavior, or set notation, or a couple of the different things we talked about, there are other videos. Go ahead and watch through those as well to get a little bit more information and a little bit more in depth about what we are talking about here. As always, if you have any questions, let me know. I'm happy to help, or your teacher's happy to help, and we can go a little further for you with this. Hope you enjoyed the video. Hope this makes sense to you. Have a fabulous day.